Hey everyone, so this is a video about Taylor's inequality. It's going to use the new version that I showed you in the last video, and this is going to be us solving 7b from assignment 9. So we were dealing with the function ln of 1 plus x, which has this Maclaurin series. So we're dealing with a Maclaurin series, or the Taylor polynomial centered around 0. So in this case, we have a equals 0, and it's given to us in the question, and we want to find the upper bound on the error for k equals 3 in two cases. The first case is when x is equal to 1, and the second case is when x is equal to negative 0.5. So we've got here, k is 3, right? So the absolute value of r, 3 of x, well, this is just equal to, or this has to be less than or equal to, m4, because k plus 1 is 4, over 4 factorial times x minus a is 0, to the k plus 1. Great. So here we've got two cases. We want to find this for for x equals to 1 and x equals to negative 0.5. So let's do that. M4 will be different in each case. So let's find out what M4 will be for each of these ones. So M4. So in the first case, x equals 1. Well, M4 has to be larger than or equal to the max of, well, we have a is 0, x is 1, so it's going to be the bottom case, right? So it's going to be the bottom case. So c belongs to 0 to 1 of f to the fourth derivative of c, but I've got that right here, right? So fourth derivative of c, and x is just c, right? K is 3, fourth derivative. So I've got the fourth derivative in here in absolute value signs, evaluated at c, right? So it's just at c. So we know that this is going to be biggest when the denominator is smallest. So the denominator is smallest on this interval for c equals 0, right? If I pick c equals 1, then it's going to be much bigger. So you would pick c to be 0. So this is equal to the absolute value of negative 6, and that's just 6. Well, what about the case where we have x equal to negative 0.5? So we do the same thing. So we have M4, and sorry, this one was M4 is equal to 6, right? So M4 has to be bigger than or equal to 6, we just pick 6. So M4 here has to be bigger than or equal to the max of c between negative 0.5 and 0. So c belongs to negative 0.05 to 0 of the same thing, right? This is still after the k plus 1 derivative evaluated at c. 1 plus c to the 4. And this case, again, we still want the bottom of the denominator to be the smallest. So if the denominator is the smallest, well, I would plug back in c to be negative 0.5, right? Because that would give me the smallest denominator. So let's do that. And this is going to give me the absolute value of negative 6 over 0.5 to the 4. Or in other words, this just gives me 6 times 2 to the 4. And this gives me, what is it? 2 to the 4 is 16, so that gives me 96. Right? 0.5 is 1/2, so it's like I flip it on the top, so it's a 2 to the 4. If you don't believe me, check it on your calculator. Alright, so for this one, I would pick M4 to be 96. So let's see what happens when we actually try to calculate this R3 of x. So for part 1, R3 of x is less than or equal to M4. I've picked 6, so it's over 4 factorial times x, well, that's 1. X is 1, right? So x is 1 in this question. I should have probably gone back here, and I'll just write 1. All right, so this is 1, and this is less than or equal to 6 over 4 factorial times 1 to the 4. Right, my bad. K plus 1 up here, this should be 4. If you didn't catch that already, that should be 4, because k is 3. So this is equal to 6 over 4 factorial. So this is equal to 1/4. Now what about the case where R3 of negative 0.5? Negative 0.5. So this is going to be less than or equal to, and I've picked M4 to be 96. 96 over 4 factorial times 0.5 to the 4. Sorry, negative 0.5 to the 4. And to be super safe, you could put absolute value signs here. Absolute value signs here. Hang on a sec. So absolute value sign, negative 0.5 to the 4. The reason why I didn't the first time was I was thinking it's to the power of 4, it's even, it's positive anyway, right? If you take something to the power of 4, it's always going to be positive. Anyway, so let's see what we get. So this is going to be equal to 96 over 24. Well, that's 4. 96 over 24. 4 factorial is 24. Times 1/2, because I could take the absolute value sign of the negative, so it's 1/2 to the 4. So this is equal to 4 over 16, and this gives me 1 over 4. So that's why for both x equals 1 and x equals negative 0.5, we get the same error bound. So the lesson here is to use the other version of Taylor's inequality I showed in my last video. And this is why I showed you what I did in class on Friday. All right, great. Hope that was helpful. If you have any comments, I realize I should have taught this version first. It's just that one of the ones that I found was in fact the one I taught you first. So yeah, but this is also valid, and I would recommend that you use this one before the other one. Great, good luck.